Objective 2. Find the inverse of an exponential function and a logarithmic function. So we've worked with inverses before, mainly with radicals and powers. In this case, we're going to work with logarithmic functions and exponential functions. The first thing to consider before you start this, I'm going to do two examples and ask you to try two examples that are very similar to mine, is that if you're given a logarithmic function, hopefully you know by now that its inverse function is going to be written in exponential form and vice versa. So if you're given a function in exponential form, its inverse is going to exist in logarithmic form. All right, so just keep that in mind as you're working through that, or working through these problems with me. The first step, I've loosely written out some steps that I will follow to find the inverse. Step 2 looks different for each function. It just depends on what type of function or what's happening within the function itself. But they're similar. They're actually the exact same as what you've worked with before. The first step is to switch the x and the y. And remember, we can do that, and we do that because all the x values of the given function become the y values of its inverse function. So that's the process and how we go about that. So if I were to do that, I would write x equals log base 2 of y plus 6. I have just switched the location of the x and the y. Now, step 2 is to get y by itself, or isolate the y variable. And in this case, since it's logarithmic, I'm going to first begin by switching it to exponential form, getting rid of the log, all right? So if you remember from objective 1 in this topic, switching it to exponential form, I have to identify the base, and I draw my arrow to its power, and then I draw the arrow to what that's going to equal, what the log is holding in this instance. And so, again, the base of 2, so this is step 2, the base of 2 is going to be raised to the power of x, and it's going to equal the output of y plus 6. So in this case, I switched it to exponential form, and then I'm still performing step 2. I'm getting y by itself. The last thing to do in this instance is to subtract 6 from both sides. So my final answer, the f inverse of x, the original function, is 2 to the x minus 6. And if you notice, the given function was logarithmic. Now its inverse is exponential. Please keep that in mind. That's very important. So at this time, would you please pause the video and try number 2 on your own, and then check your work with mom. All right, you should have tried number 2 on your own by now. I'm going to go through my process. The first step is to switch the x and the y locations. Log base 4 of y minus 10. And then I begin by switching it to exponential format. So 4 to the x equals y minus 10. So 4 to the x equals y minus 10. And in this case, I just have to add 10 to both sides. So the inverse is 4 to the x plus 10. And I'm done. Hopefully your work matches mine. If not, please raise your hand so I can come talk to you about it. And then, moving on now, finding the inverse of an exponential function. We just found the inverse of a logarithmic. Now we're going to find the inverse of an exponential. So, same process, except for step 2. When you're getting y by itself, you switch to logarithmic form. All right, so keep that in mind. First step, if I'm going to do number 7, and again, if I was given this function, I would notice that it's exponential because, for one, there's no log written. Also, the variable is written in the exponents, meaning you're given that is an exponential function then. So I'm going to replace the x and the y, or switch their locations. So now it's x equals 5 to the y plus 8. All right, now, before I can switch it to logarithmic format, if you remember, I can only do that when the base and its power are by itself, meaning in this case, the 5 and the power of y are by itself. So before I switch it to logarithmic format, I have to isolate this piece, 5 to the y, all right? Up here, I didn't have to do that because the log was already isolated, log base 2 of y plus 6. If there was like a minus 3 over here, then I would have had to do that. I would have had to add 3 to both sides, but I didn't have to because the log was already isolated. But now I have to isolate the exponential part, or the base with the exponent. In order to do that, I subtract 8 on both sides. So now I have x minus 8 equals 5 to the y. And now, because the base and the exponent are by itself, I can switch it to logarithmic format to finalize my inverse process. So I still take the base of 5, so I know I'm going to have log base 5 of x minus 8 equals y. So if I write that, log base 5 of x minus 8, I can group them now because they go together, equals y. And to finalize it, I write it in inverse notation. F inverse of x equals log base 5 of x minus 8. And I'm done. So, y to the 5x plus 8, its inverse is log base 5 of x minus 8. It's supposed to be an 8, not a 5. Alright, go ahead and pause the video and try number 9 on your own. At this point, you should have tried number 9 on your own. I'm going to show you my work. First step is to switch the x and y locations. And then the second step is to start isolating y. In order to do that, I have to subtract 4 on both sides. So now I have x minus 4 equals 2 to the y, and then I switch it to logarithmic function. So it's going to be log base 2 of x minus 4 equals y. I did that a little too fast. It's supposed to be 2 to the y, raised to the y, there. Log base 2 of x minus 4 equals y. So if I finalize that, log base 2 of x minus 4 equals y. And finally, just writing it in the proper notation, equals log base 2 of x minus 4. And we're done. Alright, before the video ends, I want to show you I want to show you one more because it looks a little bit different than what the two I've just done. Okay, so I'm going to do number 6. All right, and just keep in mind that number 6 is the same process as number 8 and 10. So for number 6, the first thing I notice is that it is written in exponential form. The variable is in the power, so I know that its inverse is going to be logarithmic. And I begin the same process, switching the locations of the x and y over 4. And in this case then, I know that I'm going to have to switch the format to logarithmic. And I do that, the first thing I have to do is isolate the base with its power. In this case it is isolated. 2 to the y over 4 doesn't have anything else on the right hand side. So I can go ahead and switch it to logarithmic. So I'm going to have the base of 2 of x equals y divided by 4. So if I write that now, log base 2 of x equals y over 4. And I'm still isolating the y value, getting that by itself. And so in this case then, I have to multiply each side by 4. Alright, and so now I have 4 log base 2 of x equals y. And one last step to incorporate the properties of logarithms. This 4, when we condense it, bring it back to the original form, becomes the power of x. So now I have y equals log base 2 of x to the 4th. And the notation, f inverse of x equals log base 2 of x to the 4th. And I'm done. So numbers 8 and 10 are just like this one. Thank you for watching.